All right. Where is the title? 4.5 limits at infinity. So I'm going to go back to the limit just for a little bit. And this starts off pretty straightforward. So for example, it's problem 1. Find the limit if it exists. So H, I don't know why they call it H in the homework, but oh, I see. This is what they want us to do. They give us an f function. They say 3x squared plus 2x plus 7. Then they tell us that h of x is equal to f over x. So yeah, I see. So this is part A. So they want to do all these, do these limits. The first h would be this. So that would simply be 3x squared plus 2x plus 7 over x, which will then become 3x squared over x plus 2x over x plus 7 over x. So this will be gone. This will reduce. We'll have 3x plus 2 plus 7 over x. So there's our basic algebra. So once we take the limit, this one we have to kind of think about it. So as x goes to infinity, this just gets infinitely large. This is just plus 2, so it'll be infinity plus 2, which is still infinite. But this guy will get infinitely small. Do you see why?
Because the larger the fraction, the smaller the number.
Yeah, because the bigger that x, the okay. So as we can see, 1 over 10 is 0.1, right? 1 over 100 or 1,000, it's even smaller. So if I get really large, it gets really tiny, right? So if it's 1 over infinity, right, as x is approaching infinity, when you take the limit, this is equal to, this first part is just infinity plus 2 plus 0. So this goes to 0, but it's still infinite. So the limit is infinite for this example. Are there any questions as to why that's 0 or why this is infinite?
Yeah, I kind of got lost on that part. Sorry.
Yeah, so but just think of it this way. If x goes to infinity, I mean, it's just super big. So that's it, right? It just gets really large. Nothing stops it from growing.
So there's no
get super
specific.
small. So that's it. There's nothing to do.
Oh, okay. That makes sense.
So now let's say we changed it and said h be f of x over x squared. So now let's see what happens. That would be 3x squared over x squared plus 2x over x squared plus 7. That'll be 3 plus 2 over x plus 7 over x squared. So now, go ahead and take the limit. So the limit of 3 plus 2 over x plus 7 over x squared, as x goes to infinity, what will this be?
Wouldn't it still just be infinity?
Well, let's look at it term by term. The 3 doesn't do anything, right? It's just 3. What happens to this piece?
Does it turn to 0?
Yeah, this is going to go to 0.
Okay.
This is, I just smeared it. This goes to 0. This also goes to 0, but much faster. But at the end of the day, these are 0, so the only thing left is 3. So the limit is 3. So when you're dealing with infinity, you can make these assumptions because when a fraction is infinitely small, it's going to go to 0 eventually. Does that make sense?
Yes.
Okay, we'll do one more just for fun. So example 1 has 3 parts, so let's go ahead and do, let's say the denominator is even bigger.
Oh, never mind.
Right, so 3x squared over x cubed plus 2x over x cubed plus 7 over x cubed. So this will all reduce to leaving you with 3 over x plus 2 over x squared plus 7 over x cubed. So when you take the limit, what do you expect?
It would be 0.
Yeah, each one is 0. That's our limit. So let me give you some quick notes in just a second. I have to give you some time to look at this.
So,
Hmm?
when it equals 0, does that mean that there's no limit, or what does that mean?
Yeah, the limit is 0. That's all.
Oh, okay.
So here, limit was 3. Here was 0. Here it was infinite. Okay. You guys cool on this page? Or no?
Yes, sir.
So for infinite limits, all you have to do is look at the degree. Here's some quick note here. If the degree of the numerator is larger than the limit is infinite. If the degree of the denominator is smaller than the limit is 0. So something like this. Right? This limit, if this is going to be a limit, right? This would happen. But if you had something like this, what's going to be 0? Just some, this is not proper notes. I'm just trying to give you a big picture idea. The degrees are the same, that's when things are different. Same, take the coefficients of the highest degrees and divide them. Numerator over denominator. Well, let's show you some example where that happens. Define each limit if it exists. Okay. Okay, so let's see here the degree of the top and the bottom. You agree it's the same, right? Let me make it more. That's what we'll do like that. So if they're the same, all you gotta do is take the coefficients and divide them and you'll be done. But if you wanted to show work, what you're supposed to do is divide each term by the highest power. Okay. So as you can see, these are going to cancel out, right? So you're going to be left with 1 plus, I don't have room there. Let me do it over here. 1 plus 8 over x to the 4th over 1 minus 6 x to the 4th. So when you take the limit, you see that these will go to 0, right? Leaving you with 1 over 1, which is 1. Does that make sense?
Yes, sir.
So, but technically you can avoid this work if you look at the numbers. You just look at these numbers right here, two biggest ones, and you divide them right here. So you kind of go straight to here to get 1. If this was like a 2 and a 3, then this would be 2/3. Yeah, take a short. Well, actually, they're coming back in just a second. There's a technique. actually, let me double check something before we go too much further. This is what we did at the beginning of count one, right? You remember? So I'm wondering, check if it's time to use the other technique. One moment. So section 4.5. I'm pretty sure it's time to use L'Hopital. But I want to make sure first. Look at the footnotes. Shit. Oh, it's only for integer. Maybe they say it for chapter. I think it should be here. That's okay. Let's keep going. I'll get too distracted here. 4. If it comes up, I'll go ahead and use it. Because this L'Hopital is only important when you have infinity or 0 over 0. So it's not all the time. It's only for those forms. So far we haven't had that. Here we did have it, right? So we could have done it there, but it would have taken many steps that it would have been worth it. So let's see. Let's do the next part. So let me show you the shorter way. Let's say we had the limit. Let's do a similar one to this. Let's say we had 4x to the 4th plus, we're going to say it's 7 plus 8 over 7x to the 7 plus 2. Right, so we can just say, well, these numbers don't matter. These will overpower each other, leaving me only with the constants. That is my limit. So when things go to infinity, this is what happens. Okay. Yeah. So they're gonna. I mean, yeah. If you show the work, they will go to 0. But you can also think of it as they're so negligible. Why even care, right? It's like, you know what? This is where these guys are going to infinity. So plus 8 plus 2 don't really matter in the grand scheme of things. So we only look at these guys, but they cancel each other out. So eventually you get 4/7. Okay, so similarly, the limit is x to the 4th plus 8 over x to the 5th minus 6. Let's say we'll make it a little more complicated, I guess. So what is the highest degree on the top? And the bottom
4.
is 4 and 5. Yeah. You guys are right. So since the bottom has a higher degree, this is going to be 0 right away. This thing will overpower everything else. See what I'm saying? Like the X
Yes, I got-
squared, yeah, X don't matter. What's up?
Yes, I guess the excellence I've been looking at this like type of math.
I'm sorry.
Saying X are the right.
Kind of cutting out. Yeah, we're only looking at the highest power. That's all we're doing. So the first thing, figure out what's the degree of the top and bottom. Degree means the highest power of all the terms. So 4 is the highest power, so that's the degree. Degree of the numerator is 4. Degree of the denominator is 5. So since it's bigger on the bottom, this will overpower everything when we're talking about infinity. So the bottom will blow up faster, which means it will go to 0. Okay. If you show your work, this is what we did in, I think, in chapter 2 at the beginning of the semester, right? But technically this is what's happened. So let's go ahead and move on. Any questions on number 2? Is that okay? Do one more really quick. Okay. So the limit as x approaches infinity of x to the 6 plus x squared plus 2x plus 1 over x to the 4th plus x cubed plus 2. Put 3 there for no reason. Yeah, so this would be infinite because this guy is the degree of the top is bigger. Does that make sense?
Can you explain that one more time, sir?
Yeah, so if the numerator is growing faster, right? This has a higher degree than the bottom. Then the top part will dominate. So it'll grow and completely ignore this guy, the bottom. So since this is growing faster, it'll keep getting bigger and bigger and bigger. So it will become infinity. The bottom is growing faster, it'll keep growing, which will zero out the whole thing, because if the bottom gets too big, that means it's going to go to 0.
Okay, gotcha. Thank you.
They go at the same rate, well, they cancel each other out and you take the coefficients. So those are the 3 scenarios you're going to see with infinite limits.
Right. Okay, cool. Thank you.
Okay. Guess cool on this page? Okay. Next example. Now you can, of course, we said, I think a long time ago, we mentioned that if you have two parts, you just take the limit of the whole thing. So the limit as x goes to infinity of 1 plus 6 over x will be equal to, right? So what you think about, think of it as two separate limits, right? Remember I gave you those rules for limits? You can separate them. So when you take this limit, this will go to 0, and this will be just the 1. So nothing too crazy, right? That makes sense?
Can you kind of explain that? Sorry, I'm a little bit lost on that part.
Yeah, so remember, there's the denominator has a bigger degree. So this x is growing and growing and growing.
Oh, and it becomes 0.
So it's going to zero the fraction out.
Oh, okay.
And that's just the number 1. So there is no x.
Okay, so then the limit is 1 for that.
Yeah, it'll just stay the same.
Okay.
Okay, on this guy, let's see here. X approaching negative infinity of 3 over x minus x over 7. So negative infinity behaves almost the same as regular infinity. You just have to watch out for the sign. Something might end up being negative, or the answer might be negative infinity instead of regular infinity. So right away, we can separate them. So this will go to 0 because negative 0 is still 0, so that doesn't really matter. This will go to negative infinity, but since there's a minus on it, that'll reverse the direction, so it's going to be positive. So think it as negative negative. Even though that's not proper, that's kind of what happened. If it was just a regular x, then you would say negative infinity. You see what I'm saying?
Is that because the x is on top in this fraction?
It's infinity because x is on top, but also because it's negative.
Okay,
Because it's going to negative infinity, but it's also negative, so they kind of cancel.
right. If it wasn't hold on, sorry. If it hadn't been put to the negative sign, it would have been positive. No, wait, I'm okay, I'm confused. I'm sorry.
No, you're fine. Yeah, if this was positive, then this would be a negative here. Negative.
Okay, yeah, there you go. That's what I was trying to say. Okay.
So yeah, you're right. This negative actually changes. Like if you had this is part A. So let's make up another question. Let's say it was going to 3x over 2, right? This would just be negative infinity because there is no minus.
Okay, gotcha. Okay, thank you.
Okay, well, that's pretty much it. I think it's just gonna keep repeating itself. You'll have X's on the top or bottom, but you'll have a couple that are a little weird, but it's not that big of a deal. Like this one right here, I think it might be worth doing. The limit of the square root of x to the 6 minus 1 over x to the 4th minus 1. X is going to negative infinity. So what I want you to think about is that this square root, I mean, I know this is improper because the only reason we're able to think about this is because we're dealing with infinity. So ignore the ones and realize that this is more of a x cubed, right? See what I'm saying? So that means that the bottom is actually bigger. Is that clear?
Is that because of some rule for exponents, like they subtract each other or something? I don't know.
Yeah, the rule would be this. If you change it to a fraction, square root is a half power, so 6 times a half
Oh, okay. Well, yeah. All right, that makes
is a
sense.
3. So think of that for this term. Now, if you were to divide everything by the highest power, it will get complicated because you have the root. The thing with this way is a little easier. So this will simply be 0 because this is bigger. So if you see square roots, stop and be careful because it's a little different.
So then that would pretty much end up equaling negative infinity, right? No, you said 0.
Yeah, 0 because the bottom overpowers the top. But the top is really just an x cubed. It's not truly a sixth power. Does that make sense?
Yeah, it does.
Okay. All righty. Well, I think that's it for this section. I don't think we really need L'Hopital. These limits are pretty straightforward. The book doesn't mention it, so. Let me see what the next section's about. One moment. So just do a few of them. You can only gonna have one question on the exam about this. Summary of curve sketching. But it does go really well with all the stuff we've talked about. So it's worth talking about. Okay. sketch. Y equal to x over x squared plus 4. Find all extrema. Points of inflection. Intercepts. And asymptotes. Good. All right, so first thing we got to do is take two derivatives, or at least one for sure. So y prime will be a quotient rule. Let me figure out where the quotient minus goes. It's going to be the top or bottom part times the top derivative minus the top times the bottom derivative over the bottom squared. So this is just the one, so we don't have to write that anymore. This will be 2x. And then we have this nonsense. That will be negative 2x squared plus x squared. That's a negative x squared plus 4 over x squared plus 4 squared.
You got 2x by taking the derivative, correct?
Yeah, the root of this will be 2x.
Okay, thank you.
So negative 2x squared minus that one is 1. So there's our derivative. So whenever this is equal to 0, so bottom, we don't have to worry about the bottom part, but remember we said to find the inflection points and, extrema points, critical values. You set the whole thing to 0. But this will only be 0 when this top part is equal to 0, which means you can just solve for this. So that implies that x is equal to 2 and negative 2 when you square root both sides, right?
So what do you do with the derivative again? You said it equal to 0 to find the intercepts?
The critical numbers, the possible extrema.
Oh, okay.
So these could be minimums or maximums. But we're gonna have to test around them or use a second derivative, but second derivative would require another quotient. So that might be more annoying. It's really up to you at this point. I'm gonna choose to use the second derivative, the first derivative test. test around it. Okay, so these are critical numbers. So let's pick some test points. I'm going to pick -3, 0, and 3. So the derivative is this. So I just need to know what is the sign of these test points. The y prime at 0 is 0 plus 4 over 0 plus 4, right? Which is positive. So that's all I need to know. I don't care about the number. Now let's test -3. So -3 squared plus 4 over -3 squared, squared plus 4 squared. So this is going to be positive as well. Is that clear or no? Actually, no, it's not. Negative, negative. So 9 minus, oh, yeah, this is negative. Plus 4. Not that. Right here, this is all my testing.
Did you erase the 0 plus 4, the denominator, for a reason, or was that just kind of a?
They got smeared.
Oh, okay, sorry.
I think it's on my hand. Okay, so you guys cool up to this point? We're doing first derivative testing like we did in 4.2 or 3, I think it was. So now test the derivative at 3 and see what the sign is. It's going to be, looks like it's going to be negative as well. Yeah. Okay, so looking at this, what is -2? A maximum or a minimum? No, we know that where we're negative, positive, negative.
Maximum?
This one? Or this one?
Oh, I forgot there's two. It's a minimum.
For which one?
Wouldn't -2 and then +2 be like minimums and then 0 be a maximum?
So these are my criticals right here, right? So we got to see what's happening beforehand. We're decreasing, and then right after we're increasing. So this is a minimum there.
Right.
And then over here, this going on, right?
Oh, I forgot it's not one line, it's 2 lines.
Yeah, we only have 2 criticals, right? Okay. So relative minimum at -2 comma something, relative max at 2 comma something. So I need to find these numbers, I need to plug them into the original. So if I plug in -2 here, what do we get? Let's see. Running out of space here. I have to turn the page. That's negative 1/4, right? And the other one will be positive 4. Okay, so we've done this stuff before already, but we need all of this information to sketch the graph. But that's the new thing we're doing. We're just going to sketch it using the extremas, the intercepts, and any inflection if they exist. Okay, so now we need the intercepts. Make this a little better. You guys cool on this page? And any questions on the first derivative test? This was this right here. Was testing around the critical numbers. Can't write in that corner. This is basically the first derivative test. So we did there.
Without Desmoing it, I know sometimes I get confused whether it's like one single line or if it's two, as like you were showing me right now.
Mhm. When you have you mean the critical numbers, or what do you mean?
Like when you were, when we found like the positive and the negatives, how you were like, so where's the minimum and the maximum? Well, like at first I was assuming maybe it was just one line, maybe not two different continuous ones. That's why I was like, oh, is it one line? You're like, well, no, because there's one minimum, which is going down and then goes back up. And then the other one was going up and then going down.
Yeah, so whenever you have down and then up, you have a minimum. Whenever it's up and down, you have max.
Yeah, so does that let us know we'll have two of them? Because like, that's
Yeah.
what I meant.
Yeah, you're gonna have two extrema, a
Right.
minimum and a maximum.
Okay.
Because extrema only happen at or can only happen at critical numbers. It's not guaranteed though, but it should happen there.
So because there was two of them, that there's two extremes where there was only one, there would have only been able to be one extreme.
Yeah, if we found two critical numbers, so at most we will have only two minimums or maximums.
Okay.
But not guaranteed though.
Right.
We could have had just one, so that's possible. Okay, so let's see. You guys remember how to find the intercepts?
You just set them to 0, right?
Pretty much, to find y-intercept, let x equal 0. To find x-intercept, let y equal 0. Then you try to solve. So the easy one is the y-intercept. It's already solved for y. So for y-intercept, you let everything be 0. I get 0/4, right? Which is 0. For x-intercept, I let the y be 0. But the only way that's going to be 0 is if x is 0. See what I'm saying? But this can never be 0. Only the top can. So it looks like it's the same thing. So we have a point at 0, 0, actually, it's the same location. Now we have two extrema, and we have the
Wait,
intercept.
how does x equal, or the x-intercept, how does that equal 0? Sorry.
Well, how would you, how would this be possible? Right? How would this equal to 0?
Oh, okay. I don't think it would
The,
possible.
the only way is if the top is 0.
Oh,
You see what I mean? The 0
Oh.
divided by this is 0.
oh, okay. No, that makes sense. Sorry.
Yeah, there's not much work to do, honestly. So you just, because you just set the top part to 0 and you end up just a 0.
So is that supposed to be a 0 on that side, like 0 equals x over x squared plus 4? Is that what that's supposed to be?
I'm sorry.
You see on that side where like usually the y would have been, but it's like, what is that?
This?
Was it supposed to be an x?
No, it's supposed to be a 0. So
Okay,
you plug in a 0 for the y and you solve for x.
okay, yeah. I was trying to follow his question. I was like, what is that? Is that an x or 0?
Yeah, that's, I don't know what that was. So with this information, you can kind of sketch the graph. So we have a point here, right? We have a maximum where at 1/4, right? So let's say this is 0.5. This is 1. So at 2, we have a point at 1/4, some sort of maximum. At -2, we have a, you said minimum, right? Something like this. So it looks like it might be. What else do we need? We got intercept. So, one moment. Yeah, it looks like it has this kind of thing going on. I don't know if it keeps going upward or if it keeps going down, but this is my sketch. I know for sure I go through here, and I for sure have a relative minimum and maximum, right? This right here is the relative max. This is a relative min. So they say to find inflection points that I didn't. So that might have helped get a little more accuracy, but it's okay. Does the main idea make sense though? Let me show you the graph real quick on Desmos. Yeah, looks like it, right? We have our intercept, our maximum right here. See what? Yeah, looks like it, man. There might be more than one though. I think 0 is one of them.
Wouldn't it be considered because there's a third point on there?
What's that?
Wouldn't that mean, yes, there is a third point because it's like plotted on the graph?
Well, I mean, yeah, we have a point at 0, 0, and we have these points, right? But there are also inflection points in here. Like we see how we're increasing and then we're decreasing,
Yeah.
and then we're increasing and then we start to decrease again. So there's another point in here somewhere, and somewhere over here.
Oh, I see what you're
So
saying.
there's two inflection points we can't tell what they are without finding the second derivative. But this one is pretty obvious, right?
Right.
But our sketch is almost there, I guess. But that's the point of the section, basically. Given that you know there's a maximum and a minimum, given the intercepts and points of inflection, you collect all that information and you try to figure out what the graph looks like. That's what the section's about. Does that make sense?
Yeah, so basically we're just finding key points of the graph and then just, I guess, putting the dots together or like lining up the dots in whatever way.
Yeah, pretty much. Yeah, I guess literally connecting the dots, right?
Yeah.
Yeah, that's true. Mhm. Okay. So on the Homer, you'll just choose your the graphs. They'll have ABC type stuff. So if you understand the second derivative test, the first derivative test from 4.4 and 4.3, then you can do 4.6. But make sure those are done first before you start this one. Okay.
So I have 4.3 and 4.4 done before we start 4.5.
Yeah, the ones with the I think that's the one. Hold on, let me double check the names.
Okay. Thanks. I think those are the only ones we've covered so far.
4.3 and 4.4 need to be well understood to do 4.6. 4.5 is just a separate thing that we just did with infinity. 4.1 was like the basics on extrema. Let's do one more of these. This time I'll go ahead and find everything. Okay. Let's go step by step here. So find intercepts, relative extrema, points of inflection, and asymptotes. So first derivative. Y prime will be the bottom times the top derivative minus the top times the bottom derivative over the bottom squared. Yeah. So you're gonna have x squared plus 12 times 2x minus x squared times 2x. Derivative of this guy is 2x, derivative of that is 2x. Over this nonsense square. So we'll multiply that out, you get 2x cubed plus 24x minus 2x cubed. So these are gone. That's good. Now, if we do another derivative, because the second derivative will help us find the inflection points. The second derivative will be, let's see. Yeah, it'll be the bottom.
Why are you taking the second derivative? Do you do that with all the problems, or is it just this one in particular?
We
Because
should. I didn't do it in the last one, but we should. Because it'll, for curve
Yeah.
sketching, yeah, we need to.
Yeah, I was about to say, doesn't the homework make us do it? Because I've seen them always ask us for a second derivative.
To find inflection points, yes. If they ask for inflection, then you're gonna have to do the second derivative. So let's go ahead and do it. So derivative of the top minus derivative of the bottom times the top. Then we'll square the bottom again, which would become a fourth. Right. So derivative of this guy is 24. X squared plus 12 squared. Derivative of this is a chain rule. So that'll be 2 times x squared plus 12 times derivative of this inside will be 2x times that is x squared. Yeah, I didn't do it on the line. I didn't do the second derivative last time because I knew it was going to be messy or difficult, but we should. Okay. This looks disturbing. All right. Let's see. So I'm gonna try to factor, see if I can make this pretty. There's an x plus 12 in common, right? So I'm gonna factor one of these. I'll be left with 24 times one of them minus 2x times that is x cubed times 2, so that'll be a 4x cubed. This cancels one of them, so that's cool. So the derivative will finally be 4x cubed plus 24x squared plus 24 times 12.
288.
Okay. Yeah, so they're the same derivative. It's not pretty at all. Oh well. Let me double check that I didn't make any mistakes. When I factored this, 2 times that cubed. Factored one of those, I left 1. This distributes inside, that'll be 24x squared here. This is there. 24 times 12 is here. Hmm.
Oh, did the x? Oh wait, no, never mind. That's you did the derivative. That's why the x fell off. I was gonna say I think the
Yeah.
x fell off from the 24. Then I realized you took the derivative of that. So never mind.
Gotcha. Yeah, I'm trying to see if there's an error because right now I don't know how to make that, how to solve for x here. This cubic. No, it's not pretty. Was the first derivative okay? Hope so. Formula is g f prime minus f g prime 2x is 2x cubed. 2x times that is cubed 24. Yeah, that's fine. Let me see. F feel like something's wrong with second derivative.
Derivatives are so complicated.
See it yet, though.
I hate this section.
But yeah, this is why I'm not gonna ask too many questions about this.
I tried my best on the last exam and I didn't do too hot. It was just a lot to take in.
Yeah, same here. I thought I was the only one.
Oh, thank God. I tried my best early. I'm like, you know what? I could have done worse. I could have done better, but it is what it is.
Well, we'll see. I haven't graded it yet. So no worries.
At a point, I had to start guessing. I was like, look, I remember the steps. I just don't remember how to proceed. I'm like, I'm just gonna guess.
Yeah, same.
I was like, I swear I'm not doing anything fishy. I'm just trying to remember how I did it on the review.
Uh, 24x. Oh, up here. Yeah, it looks. How is this? Where did this come from? Oh, that's the. Yeah, there should be 24x right here, shouldn't it? I don't know where that x squared came from. Yeah, you do it down here. I don't know why I started. What the hell happened there? So yeah, that means that all this is messed up. Okay. Yeah, I was an algebra error, sorry. Yeah, there's no way you can solve that for the inflection points at this point. Okay. Now we're good. Sorry about that. So I'm going to factor this and this here, just like before. So you'll be left with a 24 times x squared plus 12 minus 2 times 2x times 24x. That'll be what? 96. Yeah. And then that should be 1. This counts as one of those, so that was still the same. We have 24x squared minus 96. He said 24 times 12 is 288. There we go. This looks maybe a little better. Okay. Yeah. I think this would be like an AC method type thing. Or we could do what's it called? Quadratic formula. Either way. So you factor out 24, let's see if it comes out. Yeah, sure. They both had 24 to begin with. So 288, that'll be x squared minus 4x plus 12. That should factor nicely. I hope. Really hope so. All right, so we got the second derivative. And we got the first. So now we're ready to start finding critical numbers and inflection points. And we can also use this to test the extremas with the critical numbers. All right. Okay. You guys cool on this page? Any questions on the derivative? We did a quotient rule right here. We did a quotient twice. Once for the first derivative. And then we did a quotient on this guy here. And then we just did a bunch of algebra to get it down to this. That's all that's happened so far. Okay, turn the page. Let's start finding the critical numbers. So I'm gonna write you some notes in case you forgot. To find the critical numbers, set the derivative equal to 0. So we have x over x squared plus 12 squared. So set it equal to 0. When is this equal to 0? Only one place. So we only have one critical number at x equal to 0. That's the only way this will be 0. To find the inflection points, set the second derivative equal to 0. The second derivative is equal to let's see, I already forgot what it was. Got 24 in the front. X squared minus 4x plus 12. So when is that equal to 0? Well, the only way that will be 0 is when this is 0. Uh, 6 plus 2. So two inflections at 6 and -2. Yeah, that's not coming out, is it? No. Damn. Yeah, I'm getting really hungry. Let's see. Double check everything again, because as you all well know, ocean rule sucks. Let's see here. We got 24x over this. Derivative top times the bottom. Derivative of this guy times the top. Going to be a chain rule. So bring that down, times the inside 2x, and that was already there. I factored this guy out from both terms, leaving me with this and this guy. Oh, there it is. So, the square, man. Dang it, I'm making some mistakes today. I'm sorry. Second derivative got me twice. Do you see the mistake? Yeah, so it'll combine into 2 terms, not 3 terms. It's gonna be a little prettier. Yeah. So this will actually be, so 96 minus 24 is what? Sorry. Negative 96 plus 24. Oh man, it's negative 72x squared plus, I don't trust anything anymore, 12 times 24.
Same.
All right. These have what in common? 24? Yeah. So we could factor a negative 24 here. So that'll be actually, I think something bigger. I think 72 goes on above, right? Yeah. Even better. This will be x squared minus 4, right? I'll call that negative. Yeah, please double check me at any moment. I do not want to start over. Okay, so we're gonna use this guy over on the other page. Okay, so right here, the issue was that I had these 3 terms, which was now going to factor. And you'll see that when it's impossible to factor, you'll start to notice there must have been an algebra mistake somewhere, because they're supposed to work out. Yeah, if it looks too ugly, it's like, oh, there's something wrong. So to solve this, you just set the top part equal to 0. So x is equal to plus, go to 2 and negative 2. These are reflection. Finally. Okay. So any questions on the derivatives or any questions on the critical numbers or inflection points?
You got two because you distributed it out, right? That's how you got two.
Yeah, to get to 2, let me show you real quick. It
Okay,
won't take long.
okay.
You divide both sides by 72, so this doesn't really do anything. Right? Still 0. Then you move the 4 over and you square root both sides. You have to put the plus or minus when you square root. Okay. So these are the inflections. Okay, so now we can plug in the critical number to find the extremas. You can plug it in here. We'll know if it's a maximum or minimum. So plug in critical number into second derivative. So y double prime at 0 will be negative 72 times 0 minus 4 over 0 plus 12 cubed. So this would be negative, which means concave down, therefore maximum. Okay, so we found the extrema, found the critical, found the inflection points. Now we just need to find the y values, right? Because all I have is the x values right now. So we need the original. So plug in x equals 0, x equals 2, x equals negative 2 to find the y values. So 0, 0, 0 is 0. So max at 0, 0. Plug in 2, we get 2 squared over 2 squared plus 12, which is 4 over 4 plus 12. So we have 2 comma 1/4. And if you do the other one, you only end up with the same thing. All right, so now I have the y values, the x and the maximum. Okay, now we can do the sketch. We got everything we need, except the asymptote. You guys remember how to find asymptotes from college algebra? Also, before we move on, is there any questions on what we did here?
The reason why there's a there's a -2. Never mind. Where'd you get the -2 from?
Yeah,
Oh,
if like a
because you-
-2, they're gonna be squared, so it's gonna be the same outcome.
Oh, okay.
But I didn't do it.
Never mind. I see.
You guys cool on this page? We're almost out of time, so let's see if we can discuss this guy. Right, so we have we said maximum, right here. Yeah, something like this going on. We have an inflection point at, say this is 0.5 and this is 1.25. So actually, it was a 0, 0, or was it? Hmm. Oh, shit. Well, there. Negative times negative. Positive. Concave up. So it was a minimum, not a maximum. That makes more sense now. So change all the maxes to mins. Pretty much. Somewhat. So it's going to be going, there's a minimum here, right? So it's going to be going up here, and then suddenly it changes concavity. It's going up here, increasing, increasing, and then starts to decrease. Some weird shape like that. Something like that. Of course, I cannot draw. Apparently, I can't do anything today. We are to graph this guy. Get x squared over x squared plus 12. Yeah, it kind of looks like it. You zoom in a little more. Yeah, something like that. If we do Desmo, they're probably prettier. Let's see here. Yeah, kind of clear. Original. X squared. So it's 12, right? Plus 12 on the bottom. Yeah, so here it is. And our inflection points were the -2 1/4, right? -2 1/4. So we can see right there. Minimum starts to go up, and then it starts to decrease after that. Decreasing. So the change in concavity here. But I guess we'll stop here because these problems take a long time. We don't have time for another one. So again, I'm not gonna put too many of those on the test. Might just put one at the most.
Oh, thank God, because I was gonna say, sir, please don't do this to me, because I won't make it out alive. Please.
But yeah, the sketching, the only reason it's worth talking about is because sketching tests you over. What's it called?
Someone asked a question about the homework. Which one
No,
are you?
I'm gonna move. I'll move it. No worries on that. But yeah, this section is testing you over all of chapter 4, pretty much. So that's why it feels so difficult, because you gotta make sure everything else makes sense. Yeah. I guess I'll see you Wednesday.
Are you starting a separate room for your office hours, sir?
Yes, I am.
Okay, cool.